Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like and appreciate what I'm doing, please don't forget to share my videos to your friends and your friends' friends. That's one way you can help me promote my channel to keep me going, inspired and refreshed. Now, if you find my videos important and interesting to your studies, also don't forget to subscribe. Analyze the non-sway frame shown below by moment distribution method by determining the moments at the joints. EI is constant. So we'll just determine the moments at the joints because I already presented this in slope deflection equations. In fact, I draw the shear force diagram, the bending moment diagram, as well as the sketching of the elastic curve. So let's just verify results by this approximate method. So for this frame, the relative stiffness of AB is 1 over 5 because we expect uh, moments at A and B. For BC, it's 1 over 9. For BD, it's 1 over 8. And 1 over 6 for CE and 1 over 8 for BD. So let's have the figure and the tabulation. The distribution factor for AB is 0. Then for D and E zeros, here it's negative 1 over 5 divided by quantity 1 over 5 plus 1 over 9 plus 1 over 8. So we have negative 72 over 157. Replacing 1 over 5 by 1 over 9 in your calculator, negative 40 over 157. Replacing 1 over 9 by 1 over 8, we'll have negative 45 over 157. Here, it's negative 1 over 9 divided by quantity 1 over 9 plus 1 over 6. So it's negative 0.4. So therefore, here it's negative 0.6. Then 0 and 0 here for fixed joints. The fixed moment here is negative 35 times 5 square over 12, so negative 72.917. By symmetry here, it's positive 72.917. For BC, fixed moment, negative 35 times 9 square over 12. So it is negative 236.25. For CB, it's positive 236.25. And for the rest of the members, 0. So let's now distribute for this joint. So this will just absorb moments from the other end. So 0, lock. Then quantity is 72.917 minus 236.25. That's the unbalanced moment. Times negative 72 over 157. So we have 74.907. So lock. Replace negative 72 by negative 40 in your calculator. So 41.614 lock. Replace negative 40 by negative 45. Then put the value here. 46.815 lakh. Then distribute 236.25 times negative 0.4, so negative 94.5 lakh. Then replace negative zero point 0.4 by negative 0.6, put the value here, negative 141.75 lakh. Then the rest, no more. Next is we carry over, so 0 here, half of 74.904 is 37.452. Half of negative 94.5 is negative 47.25. Half of 41.614, put the value here, 20.807. Then half of negative, of course, 0, 0. I will not just put the value there or put the value there. Then half of negative 141.75 is negative 70.875. Then 0 here. And half of 46.815 is 23.408. Then distribute 37.452 times 0, it's still 0 lakh. Negative 47.25 times negative 72 over 157. Put the value here, 21.669 lakh. Replace negative 72 by negative 40. Put the value here, 12.038 lakh. Replace negative 40 by negative 45 in your calculator. Put the value here, 13.543 lakh. Then 20.827 times negative zero point 0.4, negative 8.323 lakh. 20.827 times negative zero point 0.6, negative 12.484 lakh. Then carry over. So 0 here, half of 21.669 is 10.834. And 0 there. Half of negative 8.323, negative 4.162, half of 12.038, put the value there, 6.019. Then distributed momentary is 0, so 0, then half of 13.543 here. Distributed momentary is 0, so half of negative 12.484 is negative 6.242. Then here 0, then half of 13.543, put the value here, 6.772. Then distribute 10.834 times 0, it's 0 lakh. Then negative 4.162 times negative 72 over 157 is 1.909 lakh. Replace negative 72 by negative 40, put the value here, 1.06 lakh. Replace negative 40 by negative 45, put the value here, 1.193 lakh. 6.019 times negative zero point 0.4, negative 2.408 lakh. 6.019 times negative zero point 0.6, put the value here, negative 3.611 lakh. Then the rest 0, 0. So carry over. Half of 1.909 is 0.9545, half of 0 is 0. Half of negative 2.408, negative 1.204, half of 1.06, 0.53. Half of, remember 0 here, so 0. Then half of negative 3.611 here, negative 1.806. Then half of 0, 0 there. Then half of 1.193 here. Then distribute 0.9545 times 0, it's 0 lakh. Then negative 1.204 times negative 72 over 157, 0.5522 lakh. Replace negative 72 by negative 40, put the value here, 0.3068 lakh. Replace negative 40 by negative 45, put the value here, 0.3451 lakh. 0.53 times negative zero point 0.4, negative 0.212 lakh. 0.53 times negative zero point 0.6, put the value here, negative 0.318 lakh. Then the rest 0. Carry over, half of 0 is 0, half of 0.5522 is 0.2761, and that's 0. Half of negative 0.212, negative 0.106, half of 0.3068 is 0.1534. Then here's half of 0 is 0, then half of negative 0.318, negative 0.159. Half of 0 is 0 here, then half of 0.3451 here. Then distribute. Maybe this is the last round, so we have to lock it finally. Anyway, we ran out of space also, and this is considerable, but that small moment anymore. So negative 0.106 times negative 72 over 157 is 0.0486. We lock it finally. Replace negative 72 by negative 40, put the value here, then lock finally. Replace, so negative 0.106 times negative 45 over 157, put the value here, 0.0304, then lock finally. 0.1534 times negative zero point 0.4, negative 0.0614, lock it finally, times negative zero point 0.6, put the value here, negative 0.092, lock it finally. Then here, 0, 0. So, half of negative 0.092, negative 0.046, so lock it finally. Half of negative 0.0304, put the value here, and lock it finally. So adding the moments here, you have negative 23.4, so here 172, here neg positive negative 233.926, then here adding 61.926, so here adding 158.255, then adding these values, negative 158.255, so that checks. Here adding negative 79.128, then here adding 30.964. So therefore, moment AB, moment A is 23.4, negative 23.4 rather. Moment BA, 172 positive kilonewton meter. Moment BC, negative 233.926 kilonewton meter. Moment BD, 61.926 kilonewton meter. Moment CB, 158.255. Moment CE, negative 158.255 kilonewton meter. Then moment AC, negative 79.128 kilonewton meter. Then moment DB, 30.964 kilonewton meter. So that's it for this problem. Then compare these moment values. Remember, these are just approximate but very close to the answers to slope deflection equations.